Okie doke, time for the last set of videos, and I'm planning 3 videos here. 2 on like consumption patterns and competition for status, and then 1 kind of rounding things off, talking about this. Well, you'll see, it's under the title, Is Unsustainability Sustainable? The consumption pattern stuff is basically, as you know, we've looked at trying to understand what's been going on the last 50, 100 years and what are the policy implications. And one of the things we found out is that technological change isn't everything. It seems to be super important what consumers choose and what consumption patterns they choose, and we want to shift consumers onto consumption patterns that have low impact for the environment. But how do we do that? Of course, according to Solow, we can sort of do it with Pigovian taxes and so on, and then the environmentally damaging stuff gets more expensive and we'll shift. But what if consumers just really like this environmentally damaging stuff? And what if, as we get richer, we tend to shift into that kind of stuff, which seems to be, at least to some extent, the case? Why is that, and what's going on? One possible thing that could be going on is status competition, and that's what I'm going to talk about in the next 2 videos. I'm not going to be using the pen and doing much math, because it's kind of too much to go into in depth. But I just want to take you through some ideas which will also be, to some extent, revising what we've done earlier in the course. Okay, I'm just going to pause the video here and turn the light on. Okie doke. So, what have I got for you? Competition for status. Intro. That is the first video. Right. So, the question which we're posing in these 2 videos together, the next 2, is: are we sacrificing leisure time and damaging the environment, driven by competition for status? The basic idea is, if we're competing for status, that's like a zero-sum game. Not everybody can win that game, right? We can all win the game of consuming more, at least in the short run, if that's what we get utility from. But if we get utility from high status compared to other people, that's a zero-sum game. And if we put a lot of resources into that game trying to win it, that's probably not an optimal allocation. If we could coordinate on something else, it would be much better. And is this phenomenon increasing importance over time? Well, there's lots of evidence that we do in fact make choices based on trying to affect how others perceive us. Okay, if you want to have a look at a paper on this, there's a super interesting paper in the Quarterly Journal of Economics there. So if this is true, then U being a function of consumption, utility a function of consumption, is not true. We need a more complex utility function, right? So here's a form of consumption that's clearly about impressing other people, right? So then U as f of c is not working. Okay, here's some more. Is this U as f of c, or is it something else? Is it about impressing other people? Okay, so how do we capture some of these ideas in a conceptual model? And we're also going to bring in some environment into our conceptual model later. So here we have a household and the firm. Household supplying labor, which we're now calling H, and consumption is just productivity times H. So this is an extremely simple model. There's no other input, right? The only input is H. Labor productivity is A. Production is AH. And utility is a function of consumption, which is the same as production. And then let's just assume that A grows exogenously at rate G. What about if we want to add environmental quality to this? So that's about what's going on over there, right? That's going to feed in. Quality of that environment is going to feed into the utility function. But how is that affected by what's going on the right-hand side of the picture? Well, we need to add some pollution, and we can do that, as you know, by adding a resource extraction sector where the resource is an input into the final goods sector, and burning that resource or whatever creates pollution. Okay, so far so good. And then this is the based on this model, we can do this kind of analysis. These are productivity possibility. This is the productivity possibility frontier, right? I don't know if that. Do you see my cursor here? I'm not sure. But that's the productivity possibility frontier. You can achieve any points along that line or underneath it. And when we have very low A, we can't do a lot. We can only, if we do nothing, we'll be at this top corner and have no consumption and perfect environmental quality. If we just literally just do everything we can to destroy the environment, we'll be there and still have no consumption. If we maximize consumption, we'll be bringing down environmental quality a bit, and our optimum will of course be somewhere pretty close to this point where we're maximizing consumption, because we've hardly got enough to eat here. But then as the curve smooth out like this, we're getting more and more productive. Then under laissez-faire, if there's no environmental regulation and all environmental damages are external to the firms, we'll just move down like that, and towards, as we hit the y-axis, the environment will collapse and everyone will die. But under optimal regulation, or first best, we expect to see something like this. And these curvatures will depend on sort of elasticity, substitution, and so on, details of how flexible firms are in reducing their emissions and how flexible consumers are in trading off environmental quality against consumption. If consumers are inflexible and firms are flexible, then we'll head up to this corner, to the top right corner. And this is building on, among other things, my paper from 2020 and of course earlier work. Okay, back to the more basic model. What about leisure? What if we add leisure to the utility function? Then we've got H, labor, and L, leisure, and we normalize the total amount of hours to 1, so we have L plus H is 1. And now we've got leisure in the utility function. What happens now as A goes up? Well, now instead of the PPFs, we have the household budget constraint. And when A is very low, the household can choose point. If it's going to spend its entire budget, it can choose points along this line. It can work not at all, and have full 100% leisure and no consumption, or it can work like crazy and have no leisure and maximize consumption. And now it's just a straight line. The more we work, the less leisure and the more consumption for a given household for a given A. And as A goes up, this line rotates outwards, right? Okay, and what do we choose? Again, it turns out it depends on how substitutable leisure and consumption are for the household. If the household is super happy to substitute, then here it's like, oh, I'm very unproductive. I'm super happy to substitute between labor and leisure. Since I'm so unproductive, I might as well take leisure because leisure is cheap and consumption is expensive, or I have to, so I'm very happy to substitute them. So when productivity is low, I go for loads of leisure. When I'm highly productive later, then I choose to work a lot because I can earn more per hour. If we have a unit elasticity of substitution between leisure and consumption, like a Cobb-Douglas, then we would see constant labor hours over time as productivity increased. If they're poor substitutes, worse than Cobb-Douglas, negative elasticity substitution, elasticity substitution less than 1, that epsilon that we often have becomes negative then we would see this, that when we're highly unproductive, we have very little leisure and very little consumption, and as productivity increases, we want more of both. We're not very happy substituting one for the other. And of course, this is more or less what we see in reality, right? When we're very unproductive, we work like crazy to have enough to eat, and we have very little leisure. So we have little consumption and little leisure. As we get more productive, we want both more consumption and more leisure. But the weird thing is, that's what we see over most of history, or most of the last couple of 100 years, but the last 20, 30, 40, 50 years, depending on which country you look at, the amount of leisure we take has leveled off. And that started in the US, which was the leading economy at the time. In the 50s and 60s, this leveling off started, and it's come over the last 20, 30, 40 years, it's come to Europe as well. Okay, so this is kind of surprising. That's just some data showing that. That's kind of surprising, so how do we explain that? Or how might we explain it? One possible way to explain it is through competition for status. So if we throw in utility is a function of consumption, leisure, and relative consumption, what happens then? It turns out then that we get exactly this tendency, that under laissez-faire, we see labor supply leveling off over time, but in first best, if the status competition is corrected by a coordination between the households, they will all agree to chill out more, take part less in this consumption race, and have more fun, and everyone will be happier. Okay. The basic idea is that, let me see, am I going to show you? Yeah, I guess. Based on this utility function, remember these three arguments of the utility function are poorly substitutable for each other. When we're poor, we have little consumption, little leisure, but relative consumption, if the households are all the same, is 1. Okay, so we've got one of these and hardly any of this and hardly any of this. They're poorly substitutable, so we don't care about this. As we get richer, we choose more of this and more of this, and we don't care about this. Okay, now imagine we're very rich, very productive. Assuming we haven't stopped working, we have lots of consumption. See, this is huge, but now this is still locked at 1, right? Because if we're all the same, but we've all got richer together. So this is still 1, this has got huge, this is at most 1, because leisure is limited, right? So now, this is excessive, we're not bothered about this anymore, and now we're trading off leisure and relative consumption. And of course, if we could all agree, we would agree to ignore this, but each household, not having agreed in advance with all the other households, knows that the more that particular household works, the bigger its CI will be compared to C. So each household has the incentive to think about this and try to work harder to keep their relative consumption up. But in the end, everyone does the same, and you have this. That's why it's a coordination problem, right? So when we're poor, we trade off C and L, and as we get richer, we choose both more C and more L. When we're super rich, we trade off L and C over C, and they both tend to be constant. Okay, we end up in this steady state trade-off with a fixed amount of leisure and fixed amount of CI/C. But you might say, can't a household just chill out more? This is crazy, I'm going to chill out more, but everyone else is still working like crazy to keep up with the Joneses. I chill out, suddenly I've got a smaller house, and not as good a car, old clothes, crap hairstyle, and it's like, oh, so this is the keeping up with the Joneses idea, right? Okay. So that could explain the labor supply data, but what about the implications for environment? That is what we're going to look at in the next video.